So for this first one, before you can combine two radicals together with addition or subtraction, they have to be matching radicals. So if it has a root 7, the other one is also going to have a root 7. So what we want to do is we want to try to simplify the radicals first. So I would look on the chart, 7 is prime, so I can't do anything to simplify the root 7. So that's going to stay 10 root 7. But 63 on the chart is 3 times 3 times 7. So what does that tell us when we have something like 3 times 3 times 7? So we can group the two 3's, and the square root of a number times itself is just that plain number. So that 3 is going to be outside of the radical now. The 7 that doesn't have a pair is going to stay where it is. And then we're going to bring down this negative 10. Now, what do I do with the negative 10 and the 3? They multiply. So that's going to become negative 30 root 7. So now we've simplified this 10 root 63. The simplified version is 30 root 7. And now our root 7's match. So these are called like radicals. We can combine like radicals by combining their coefficients. So we're going to do 10 minus 30, negative 20, and then the root 7 stays with it. It's like saying you have 10 of these things, and you're taking away 30 of these things, so you have negative 20 of these things, right? So that root 7 is like what you're counting, so it's going to stay as part of your answer. All right, let's do the next one. So negative 72, if you checked on the chart, would be, I think it's 3 2's and then 2 3's. Now, negative 200 or root 200 wasn't on the chart, so how can you figure out a number that's not on the chart? Yeah, so I know that 200 is 10 times 20, so I can look on the chart for 10, which is 2 times 5, and 20, which is 2, 2, and 5. And that makes 200 because 10 times 20 makes 200. Okay, so then again, I'm looking for pairs. I have a pair here and a pair here. So both of those numbers are going to come on the outside. So the negative's going to stay where it is. And then I'm going to do the square root of 2 times 2 is a regular 2. And the square root of 3 times 3 is a regular 3. And then I've got this 2 that's left over that doesn't have a pair. And then in the next one, I have a pair of 2's and I have a pair of 5's. So I'm going to have a 2 and a 5 on the outside, and then this 2 is left over on the inside. Okay, negative 2 times 3 is negative 6. 2 times 5 is 10. And then now that our roots match, we're saying we have negative 6 of these root 2's, and we're taking away 10 more of these root 2's. So in total, we have negative 16 of those root 2's. Okay, so when we're multiplying, we have to make sure we multiply every part of the first thing times every part of the second thing. Since these both have 2 terms and 2 terms, if you know how to use FOIL, you could use that. Or you can use the box where we have the stuff on the outside and we're multiplying what's on the inside. I like the box because it's easier to keep up with what you've done and what you haven't done. Okay, so on the outside we have root 6 plus root 7 times root 6 plus root 7. And then the first square, we're going to have root 6 times root 6. So what is root 6 times root 6? It is regular 6 or root 36. And if you did the simplification for root 36, you would get that it's 6, okay? Because remember, a square root is asking what times itself. Well, you're multiplying something times itself, right? So the square root of a 6 times a square root of 6 is going to equal a plain 6, okay? Now, you're not always going to have that. In the second section, you don't get that immediately. So you can't just assume it's going to be a regular number. But in this case, it happens to be. Okay, in the next box to the left, we've got root 6 times root 7. What would that be? Yeah, you've got to multiply the two numbers that are inside the roots together. So 6 times 7 is 42. They were both inside the square root, so the answer goes inside the square root, okay? Now, we may have to kind of think over to the side, what is the square root of 42? If it's not a whole number, can it be simplified, right? We know that it came from 6 times 7, and 6 is 2 times 3, and 7 is prime, all right? And we don't have any pairs there, so this cannot be simplified. So we're going to leave it root 42, okay? All right, now we're going to the bottom row. We have root 7 times root 6 again, which happens to be 42 again. You may not have that every time. You're not, going to get the same answer twice like we just did here, but we did, okay? And then in the last square, what's root 7 times root 7? 49. It's the square root of 49, which we know is 7. Same scenario as the root 6 times root 6 was regular 6. Root 7 times root 7 is regular 7, right? Okay, so now we have two numbers that are just plain numbers, the 6 and the 7, that we can add together. And then we have two numbers that are radicals. And remember, when we add radicals, they have to be matching. So do these two radicals match? Yes, they do. So if I add a root 42 and another root 42, what would that equal? It's like we have one of these, and then we have another one of these. So now we have two of those things. And we can also add the 6 and the 7 together because they're just plain numbers. All right, next one. So we've got two things times two things. So we're going to draw our 2 by 2 box. We've got 4 times negative 3 root 3 and 5 times negative root 3. All right, so first box, we're multiplying 4 times 5. That's what we've been doing since 3rd grade. Next box, we're multiplying 4 times negative root 3. What's that? Yeah, just negative 4 root 3. I can't multiply the 4 and the 3 because it's not a normal 3. It's a root 3. That's a different type of number, right? So a regular number and a root number, when you multiply them, you can't move something that's not a root inside a root to multiply it. Okay, they just kind of go beside each other, and that means whatever 4 times root 3 is. Okay, and then on the bottom row we have 5 times negative 3 root 3. Negative 15, because I can multiply the 5 and the outside 3, and then the inside 3, I don't have anything to put it together with, so it's going to stay the same. All right, and then our last square. So I've got negative 3 times just a negative makes it positive 3. And then I do have two root numbers that I can multiply now. So root 3 times root 3 is root 9. Now I need to ask myself, can any of these roots be simplified, right? Can 4 root 3 be simplified? No, it can't, because root 3 is just a single prime number. There's no duplicates that I can split it up into. So this number is all the way simplified. What about negative 15 root 3? Same thing. The root 3 is just a 3. There's no other numbers I can split it into to look for duplicates. So it's already simplified. What about 3 root 9? So 9 is 3 times 3. So I've got a pair. I can bring it on the outside. And I've already got a 3 there. Now I have another one from my pair. So that's going to become a 9, a regular 9. Now, it may not always become a regular number, but I think all the problems on Delta Math are sort of built that way, just to give you practice in simplifying things. But in this case, it is. So we have a regular 20. We have a regular 9. We have a negative 4 root 3, and we have a negative 15 root 3. Can any of these be combined? What can be combined? 20 and 9. 20 and 9 are like terms, so we can combine them. Okay, the two square root numbers match, right? They're both root 3's. So since they're both root 3's, I can combine their coefficients. -4 minus 15. If you start at -4 and you go backwards 15, you land at -19 of those root 3's. Remember, the root 3 part